or 1. Alright, that's why if both the outputs Q and Q dash are 1, that means it is not allowed. Alright, so that's why the first step not allowed. So consider second case. S is equals to 1, R is equals to 0. Now what to do? Apply. S is equals to 1 and R is equals to 0. You will get Q dash is equals to 1 because any of the input is equals to 0. My output at that corresponding NAND gate is 1. So Q dash is equals to 1 and Q is equals to 0. Alright, that's why over here Q is equals to 0, Q dash is equals to 1. Whenever the Q is equals to 0, my flip-flop will become a reset. Right? And whenever the Q is equals to 1, flip-flop is set. That's why the state is reset. Why? Because Q is equals to 0, Q dash is equals to 1. If S is equals to 0 and R is equals to 1, what will happen? Apply S is equals to 0. See over here S dash is mentioned, that's why 1 is going to be applied. Alright? And R dash is there. So whatever the state of the R, what is R? R is equals to 1. Apply 0. That means at S 1 is going to be there and at R 0 is going to be there. Alright, to the input of the one of the NAND gate. So S is equals to 1. What we are getting over here? Flip-flop is going to be reset. Why? Because that output Q will becomes 0. Right? But whenever we are going to apply over here, S is equals to 0. And what will happen? If S is equals to 0, Q will be 1. And R is equals to 0, Q bar will be the 1 as well. If R is equals to 0. That we have already considered. Alright? So, right now, if we are going to consider the third case, my flip-flop Q is equals to 1 and Q dash is equals to 0. Alright? Because we are going to apply over here S and R, 0 and 1. So flip-flop is going to be set. Now the last case, S and R both are 1, 1. What will happen? We need to check what is my previous state. Why? Because we don't know about what is the value of Q and the Q dash. That's why it will remain in the memory state. It will not change any output. It will hold its state. That's why it is called in the memory state. Alright? So Q and Q bar. So my value of Q and Q bar depends is going to be applied to the second input of the NAND gate. Why? Because S and R both are 1, 1. So we don't know the output. Alright? So how this circuit will work, that I have already explained. When the inputs are given as S equals to 1 and R is equals to 0, the output comes Q is equals to 1 and Q dash is equals to 0. That means when S is equals to 1, flip-flop is set. When R is equals to 1, flip-flop is reset. Okay? So these two are the set reset of the flip-flop. This is in the memory state, this is the not allowed state. Now what is clock SR circuit? In the clock SR circuit, we can say that a circuit which is used to remain in the memory state by using the clock signal is called the clock SR circuit. So what is the clock signal? So clock is basically the successive repetition of my square wave or successive repetition of pulse. That means it is having a 0, 1, 0, 1. Alright? Successive repetition of 0 and 1. Now, we are going to apply the clock signal to the SR circuit that we have already discussed. Okay? So what will happen? So when the clock is going to be applied, if it is 0, my circuit will act as a SR circuit that we have discussed. But what will happen if the clock is equals to 1? Okay? So when clock is equals to 1, and if S is equals to 0 and R is equals to 1, then my flip-flop is going to be reset. Output Q is equals to 0 and the Q dash is equals to 1. So what is the set state? So set state means clock is equals to 1, S is equals to 1 and R is equals to 0. Alright? So Q is equals to 1 and Q dash is equals to 0. As I have told you, the Q becomes 1 is called the set state. What is not allowed state? When the output comes against the input, this state is called not allowed. Means Q and Q dash both is equals to 1 means not allowed. This is the circuit diagram of clock SR. See, the NAND gate only accepts the true input, but over here S and R. So this block, cross coupled block, is the same as the SR circuit that we have discussed. Before that, we need to apply the S and R inputs with the clock. So we need to connect another 2 NAND gate over there. Alright? So there are total 4 NAND gate. Right? By applying clock is equals to 1 and S and R is equals to 1, my Q and Q dash both are 1, that is not allowed state. S is equals to 0 and R is equals to 1, flip-flop is reset. S is equals to 1, R is equals to 0, flip-flop is set. And when clock is equals to 0, my flip-flop will be in the memory state. Whatever may be the state of S and R. Alright? And if the clock is equals to 1, but S and R both are 0, 0, and it is also in the memory state. Right? So we have done RS flip-flop, or we can say the RS latch, because we are not going to apply the clock signal, and the clock RS flip-flop. Right? Now we are going to study the D flip-flop. What do you mean by D? D means delay. Right? Whatever the inputs that we are going to apply is going to be available at the output side for the instant of the clock pulse. Okay? So first we are going to focus on the definition. A circuit which is used to remove the clock SR circuit is called the not allowed state. So it requires a more circuit stability. Why? Because the not allowed state is present in the SR flip-flop, and we don't need that not allowed state because it may affect the circuit stability. So we are going to use a D flip-flop, right? So the circuit using the inverter between the S and the R, which reduce the number of inputs. Okay, 2 to 1. So D flip-flop has 1 input D, 2 outputs Q and the Q dash. So it basically consists of 5 gates. See, 4 gates are for NAND gate that we have discussed, the clock SR, and the another one is the NOT gate. So it requires 5 gates, right? So NAND gate 1 and 2 that forms a basic flip-flop. 3 and 4 that modifies it to the clock RS flip-flop. It is working as like this. This is the circuit diagram. Right? Inputs is there are only a single input, ACD. Right? So if I am going to convert the RS flip-flop into D flip-flop, I need only NOT gate between R and S. Alright? See, R and S is going to be connected with each other by NAND gate, or I can say a NOT gate. If I am going to use a NAND gate as a NOT gate. Alright? The single input is taken out, that is D. Remaining circuit is as it is. Now how this D flip-flop will work? Now the logic diagram. First of all, based on this logic diagram and by applying the clock signal, this flip-flop will going to be activated automatically. Alright? If clock is equals to 0 and as well as my D input is also 0, then my Q and Q bar will be in the memory state. How? Q is equals to 3, D is equals to 0, so for the first NAND gate my output is equals to 1 and the complement of D, that means 1 is available at the second NAND gate. Okay? First input of the second NAND gate and the clock is equals to 1 as well. So 1 and 1 output is equals to 0. Okay? Output of first NAND gate is equals to 0 and that 0 is going to be applied to the fourth NAND gate. So if any of the input is equals to 0, output will be 1. So QR is equals to 1. That one is going to be applied and from that another D is equals to 0. So my output for the first NAND gate is also 1. So 1 and 1 output is equals to 0. Right? So Q is equals to 0, Q bar is equals to 1. So output will continuously